Hello everyone, welcome back to my channel. So in this video we would be discussing about deadlock detection and recovery. So firstly, it has two components, detection and then recovery. So what we do is that we first detect if there is any deadlock and then we do recovery. Now how do we detect deadlock? So first is all those processes who have single instances in that diagram that we discussed, and there is a cycle. So all single instances and there is a cycle. So in that case it would be a deadlock. And the other one is multiple instances. So when we have multiple instances, then we'll use Banker's algo as we discussed in the previous video. But there would be a bit difference here, that earlier we used to consider all the resources, but now here we would not consider the resources whose allocation is 0, 0, 0. And how do we detect if a particular process is causing deadlock? So if we can't add it to the safe sequence, then it's definitely the cause of the deadlock. Now this is about how we decide for multiple instances, but why do we say that we'll have to detect in case of multiple instances even if there is a cycle? So let's understand it with the help of a diagram. So P1, P2 are the processes, and we have R1 resource and R2 resource. R2 has a single instance, but R1 has multiple instances, that is 2 instances. And let's say P1 is waiting for R2, where this instance of R2 is held by P2, and P2 is waiting for R1, where this instance is held by P1 and this instance is held by another process, P3. So now here, if it would have been a single instance, we would have had to say that okay, this is a cycle. But here we can see that, let us consider P3 process is completed. So after it's completed, it releases this instance. So that can easily go to P2 and then we can complete these processes. So that's how multiple instances case needs a different algorithm for detection. Now let's understand a few more things about this, that is recovery. So let's talk about recovery now. So now what do we do in case of recovery? So recovery has basically two easy steps, not easy steps but steps. So one is kill process or processes, and the other one is preempt resources. So first let's talk about preempting resources. Now in preempting resources, what can be the problem? So let's understand this, that a process is holding a resource and what we say that OS can take it back. Now but the OS needs to ensure to maintain the state of the process. Let's say the process moved from state 1 to state 2, but now the duty of OS is to maintain the state of the process, that is, it must roll back the process to the previous state when preempting the resource. But this is something very impractical. So that is why this is a not so practical method. So basically what happens is that we might not be able to roll back to the previous state. So that's a big problem with preemption of resources. Now there's one more problem that might occur with preemption of resources, that is that it might lead to starvation. And we've discussed a lot about starvation in various different videos, and that's something that's applicable in almost all these things. So starvation is also a cause that makes preemption of resources a bit impractical approach. Now moving on to kill process or processes. So there are two ways to do this. One is kill all processes, or pick a process, kill it, check if deadlock is still there, and then pick another process and kill it. So now in this case, there might be different criteria on the basis of which it decides which process to kill. So the first one would be the priority of the process. Then the other could be number of resources it's holding, or how much CPU time has it already taken. So that's it about deadlock detection and recovery, and about deadlocks as well. So we'll meet in the next video with a new topic.